Okay, so yesterday we talked about the acceleration getting smaller and smaller. And the acceleration we can tell from the gradient of your speed time graph. So we drew lines to indicate what the gradients are. And we saw that the gradient actually got smaller. It got less and less steep. So we conclude that our acceleration is decreasing. Okay? So next question. Explain why the graph from P to Q is not a straight line. So you need to identify where is P to Q. This is the curve over here. Now, when we usually do questions where you drop things from a height, we see that the speed time graph is usually a straight line. And we say that this is because the acceleration is constant on Earth, 10 meters per square second. However, in this case, it is a curve. This is of a parachute, a person with a parachute jumping down. So why is that so? Why isn't it a straight line? What are the forces acting on the man and the parachute? Okay, we have air resistance, what else? Weight. In our other types of questions, we do not consider air resistance, right? So we get a straight line. In this case, the air resistance is very critical to the parachutist. Why? Why is it critical that he has air resistance? Sorry? Oh yes, so that he can slow down. Otherwise he'll just come crashing like a rock, right? Then he'll lose his life. So the purpose of the parachute is to increase the air resistance so that he will slow down and he can land safely. Okay, so in this case, it is not a straight line because there is air resistance, and air resistance is actually increasing. Okay, so air resistance is acting on the parachutist, and it is increasing. Okay, as you are copying down, listen to me. The unique thing about air resistance is that it is not a constant. Suppose I am holding a book this way. Okay? Or let's say I'm holding a big piece of cardboard this way. And I walk slowly. Do I experience a lot of air resistance? A lot or little? Is it very difficult to walk with a big piece of cardboard in front of me? Easy or difficult? Quite easy, right? I'm walking, slow speed, air resistance, okay, quite difficult. Doesn't affect me at all. What about when you start running? Is it difficult? Yeah. What's the difference in these two examples? Walking and running. Speed, right? When you are running, what is your speed like? When you are running, your speed is higher than when you are walking. And you know from your experience, you can imagine the air resistance is actually greater when your speed is faster. Okay, so that's the unique thing about air resistance. It changes according to your speed. So in this case, when he was falling down, when the parachutist was falling down, the higher his speed, the greater the air resistance. Okay? So at point Q, the parachutist decelerates suddenly. Draw a free body diagram to indicate two forces acting on the parachutist. So what should we draw? Okay, weight. Where should we start drawing the weight from? Center, right? This is our free body diagram. We should start from the center downwards because acting towards up. So this is our weight. Next, what do we have? Air resistance. What we said was critical. So, air resistance. Okay, all done, huh? Let's take a look at part 2. Which force is larger? Do you say weight because I drew it larger? Which force is larger? This is at point Q. How are we going to decide? Okay, shall we say again? If the weight is larger, then do you say larger or smaller? If the weight is smaller than the air resistance, then you are saying that the parachutist will go upwards, is it? Let's see. This is our weight going down. He is initially traveling downwards, okay? His speed, he's traveling downwards. And then he opens up his parachute, and there is the air resistance. Do we expect him to be slowing down or speeding up? Slowing down. Okay, we expect slowing down. What is this slowing down telling you? What is the acceleration like? Acceleration is decreasing, right? Is negative acceleration. Okay, so what? If the acceleration is negative, what can you tell me about the resultant force? No. Yesterday we said that acceleration 0, resultant force is 0. What about today? If I tell you the acceleration is negative, what about resultant force? Yes. Also negative. This is shown from our formula. Resultant force equals to mass times acceleration. If this is 0, then this will be 0. If this is negative, then this will be negative. Because there is no way your mass will be negative, so the mass must be positive. So positive times negative will give you negative. Okay, so now? Okay. So if the resultant force is negative, what does that count? Say out. So initially we took downwards the positive, okay, because usually we say that we give a positive value to the weight. For example, if a man weighs 80 kg, we say that the man has a mass of 80 kilograms, we say that his weight is 80 newtons downwards. Okay, so today, since the resultant force is negative, that tells me that our resultant force looks like this, in the opposite direction of weight. That is how we get negative. Now, if this is our resultant force, can you tell me which one is bigger now? Is it the air resistance that's bigger or the weight that's bigger? It has to be air resistance is bigger. That tells us that air resistance is greater than the weight. That is why we are going to have a negative resultant force. Okay? So over here, which force is larger? Air resistance. Only when air resistance is greater than the weight, then your resultant force is in the direction of your air resistance. That is how you can slow down. Okay, last two questions. Part E. State the acceleration of parachutist from R to S. Let's look at our diagram. From R to S. Just by looking at the diagram, how can you describe it? Harif. How do you describe this region, R to S? Constant. Yes, it is constant. So it is a straight line and it is constant. You're referring to the gradient, right? Okay, gradient is constant. More specifically, can you tell me what is the gradient? No gradient. Zero gradient. Okay, so Harry says that over here, gradient equals to 0. And we know that is true. We learned in mathematics that a flat horizontal line has gradient 0. Whereas if it slopes upwards, it has a positive gradient. If it slopes downwards, it has a negative gradient. So Harif described this region as having gradient 0. What does a gradient of your speed time graph tell you? Yes, it tells us the acceleration. Meters per square second. So that is our acceleration. 0 meters per square second. Okay. Now let's try to imagine this portion. From R to S, there is no acceleration. So it is falling at a constant speed, right? What does that tell us about? What does that tell us about the resultant force? If it is traveling at a constant speed, 0. Why is 0? Okay, acceleration is 0. Specifically, our resultant acceleration is 0. So here, if the resultant acceleration is 0, we say that the resultant force is 0. What does that mean now? What does that mean for the region from R to S if I say that resultant force is 0? So earlier on, our air resistance was greater, right? Now, it is a different case. From R to S, this is what it looks like. Weight downwards. The weight doesn't change. And now, we say that the air resistance changes according to speed, right? So now this air resistance is going to be smaller because the speed has already decreased. Harry already concluded that resultant force is 0. That means what can you tell me about the magnitude of air resistance and magnitude of weight? Zafir, what can you tell me about the magnitude of air resistance and magnitude of its weight? That's it. So look carefully at how I'm writing it up. Magnitude of air resistance equals to magnitude of weight. All of you agree with this? Okay. What if? Okay, so this is the correct answer. Can you tell me what's wrong if I just say that air resistance equals to weight? What's wrong with this? Is there a difference between what's in weight and what's in weight? What's the key one? Magnitude. Why did I just specify magnitude over here? So what if I remove the words magnitude? Is this thing correct? What's wrong? What's wrong? Okay. Owen says they are wrong because this is not equals to this. is why you must be careful on how you phrase it. Okay, so what is the amount of air resistance? So when they say amount, they are referring to the magnitude, and that will be the weight of the parachutist. What is his weight? Really, his weight is 60? Is that his weight or is that his mass? Mass, that's his mass. So what is his weight? Okay, so the weight is equals to 60 times 10, and you get 600 newtons. So we can write that the magnitude, or you can say amount of air resistance is also equals to 600 newtons. Okay, yesterday I said that the deadline for submitting your 2013-2014 paper is today. So please tidy up your 2013-2014 paper, pass it down to the front. Person in front, please collect. And I'm going to return some of you who have submitted your 2013 paper yesterday. Some of you need to redo your questions because it's incomplete or you did it wrongly. So look at the comments that I've written for you. As I distribute this, the rest of you pass your homework down together with your completed corrections. How many of you need more time for the 2014 corrections? Okay, never mind. Let me extend the deadline. I will post this video online. You can go home and check. Go and do your corrections properly. I will extend the deadline to one more day. Sorry, over the weekend. So on Tuesday, I expect everything to be in. No excuses. Okay. If you have any problems meeting the deadline, you come and tell me first. With our remaining 5 minutes, I am going to start on the introduction for our new topic, which is work energy power. Okay, you have learned this in your lower secondary already. So most of this should be familiar with you, to you. First one. Yes, all your, you have already completed your syllabus in your lower secondary, which is why in upper secondary, everything should be like recap to you. You should be very familiar with everything. So, let's begin. Energy. Okay, these are the learning outcomes. We want to be able to identify the different types of energy. And we need to be able to recall and apply the formula for kinetic energy, which is half mv squared. We'll discuss a bit more. Gravitational potential energy, which is mgh. And we must state this important principle of conservation of energy. Okay. So, take a look at all these. What do they have in common? Energy. Can you describe what this is trying to ask? What type of energy? There's movement. The cheetah has a speed. The cheetah has mass. So he has kinetic energy. What kind of energy do you think this is? Yeah, we learned that as your chemical potential energy in food, right? In our body, we can use that to convert to the different kinds of energy that we require for daily life. What do you think Hawkeye is doing over here? Elastic potential energy. Because as he stretches his bow, he's storing up all the elastic potential energy so that when he fires, the energy can be converted into kinetic. That is in the arrow. What about this one? Solar. Okay, there is light energy. What else? Heat. Okay, so this type of light bulbs, they also generate quite a big amount of heat. And this is quite wasted, right? In Singapore, when one light, we don't want the heat. So this is not very energy efficient. We tend to use this type of light, fluorescent lamps. And what about this person on the ladder? What do you think they're trying to do? Gravitational potential energy. Anything that is raised from the surface of the earth, we say that it has gravitational potential energy. Okay, so, potential energy, there are three types we are interested in: elastic, gravitational, and chemical. So we have mentioned that just now already. And kinetic energy. Potential energy and kinetic energy, we call them mechanical energy. So you need to know this. Potential energy, kinetic energy, they are called mechanical energy. So the question, light energy. Is it mechanical energy? No, it is not. What about gravitational and potential energy? Gravitational potential energy is mechanical energy. What about elastic potential energy? Is it mechanical energy? Yes. So potential and kinetic, they are mechanical energy. Things like light energy, heat energy, they are not mechanical energy. So for example, this time, okay? Nuclear energy, okay. Some countries, for example, in Japan, a couple of years back, they had an earthquake, right? The Fukushima incident. What happened to the nuclear power plant? There was radiation leak, and that was harmful to the environment and the people living in the vicinity, right? So, what were they doing with these nuclear materials? They were trying to harness energy. So whenever you split atoms, when you fuse atoms, there is energy involved, and we call them nuclear energy. Okay? Yeah, let's look at this. You think a boy who is chopping this wood over here has more energy, or means that because he has more energy, but how do we justify our choice? The body? Maybe that's how you get to decide it. The impact on the root. Okay, getting closer. Let's look at the trouble, the problematic portion is this word energy, right? We need to know how to define it. Once we can define it, then we can justify why we say he has more energy. Okay, let's look at the definition. Energy is the capacity to work. Now, with this definition, can you justify why we say he has more energy now? Yeah, Captain America can do more work. He can chop this huge piece of wood, whereas the little boy probably cannot. So, Captain America has the capacity to do more work. We say that he has more energy. Okay? So, the SI unit for energy is the joule. Capital J. When you do your calculations, when you want to write down the unit, you must use the word. Small j, not counted. Energy is a scalar. That means it only has magnitude. Compare that with forces over here. Forces are vectors because they have magnitude and direction. Whereas energy only has magnitude. There's no direction to talk about. So we have already answered this question. Captain America has more energy. Next, kinetic energy. Remember just the first one. On the first slide, I showed you the cheetah, right? We say that it has kinetic energy. That's because he is moving. So moving objects, they have kinetic energy. Alright? We will talk a bit more about the things that affect kinetic energy. For example, the mass and the speed. These are the two things that affect kinetic energy. Okay? So that's all I have for today. Pack up your things. Remember, submit your corrections on Tuesday. Okay, class then? Okay, I'll go some later. Class 10. Sorry, Zayang. Thank you, class. Have a nice day. Yes.